Assalamualaikum warahmatullahi wabarakatuh. Today my group will present the high voltage engineering project which is entitled the class Insulator Design. We are from section 1. My name is Fatina Zira binti Maksani and this is my members Daniel Hakim bin Muhammad Razali, Nur Atika binti Yahaya and Nur Hidayah binti Saifullah Arifin. For the introduction, this project builds an insulator capable of withstanding a minimum of 132 kV continuous AC voltage and following the standard regulation by the authorities. This project analyzes the specification of modern insulators, a cap and a pin type glass insulator. The pin and cap type connection consists of a galvanized steel spindle with a forked ball on one end that couples into a socket from on top the malleable cast iron cap on the top of the adjacent insulator unit. Next, for the objective of the project is firstly to design and simulate the high voltage insulators proposed in the COMSOL multi-physics software. Next, to analyze the performance of the insulator proposed to work the electrical stress with environmental effect in the COMSOL modeling software. And thirdly, to propose a suitable high voltage laboratory test setup to test the insulator durability with the electrical stress. Next, for the scope is firstly a glass insulator with a maximum length of 1540 mm, with pitch clearance of 4200 mm, 175 mm squared, the staggered and fitting option of cap and pin, and all of this will be designed by using SketchUp. Next, to analyze the performance of the design insulator, which is the electrical stress or electric potential and the electric field by using COMSOL multi-physics software. Thirdly, the compatibility and the suitability of each type of insulator on a 132 kV high voltage transmission line tower. Lastly, the prototype will be done and tested as an HV test in UTHM laboratory, which will have a brief safety risk assessment and code of conduct. The focus of this project is on the HVDC dry and wet test.
So for the concept design, this system is meant for voltage around 132 kV, and the type of insulator we choose is string insulator with a material of glass. And as for the filling option, we use cap and pin. And this design is meant for the location which is light agriculture area. So this is the cross-sectional area of cap and pin insulator that we design using SketchUp. And this is the glass cap pin and insulator system, voltage 132 kV. This is the string insulator. So this is the electrical and mechanical parameter design of insulator that are following the IEC 305 UB40B type of insulator. So this is the characteristic of the insulator glass type, which is the material is used in this insulator is glass with relative permittivity of 4.2 and cement grout 15 permittivity air, and also the contamination set to 81, which is the permittivity of water. So there are several advantage and disadvantage of the glass insulator. So for the advantage, it has high strength of dielectric, low coefficient of thermal expansion, and long service life. As for the disadvantage, the moisture easily condense the glass surface, lead to the leakage current in the system. And next, the glass could not be cast in irregular shape on the high voltage application, and also the installation cost is very high.
Assalamualaikum, I'm Nur Atika binti Yahya, AE 170047. I will continue the presentation on the block diagram of the simulation. My group we choose the console multiphysics software as to run the insulation design that is designed in the SketchUp. Before starting the simulation in console software, we need to choose the new wizard model on the ribbon option. When it is appear in the screen, we can choose the 2D space dimension to design simulation in 2D dimension. It also can be designed in 3D dimension, but it needs a high space of the in the computer to run the simulation. Still, we choose the 2D dimension for our project as to avoid problem while compiling, analyzing, and saving the simulation file. Next, we can select the option of physics for electrostatic and study of stationary for the project file. And then we can also easily import the DXF file that of the installation design that were designed in the SketchUp to the console. Then the material can be assigned by the user depending on the type of installation needed. The parameter and the design required can be inserted and manipulated and terminate assigned by the user itself. Last but not least, user just have to click on the study to compute in console multiphysics software as to generate the result in 2D simulation that is present in the graph. It is highlighted and recommended to save the file as to avoid the circumstance that the file lost or crashed in the simulation file. And then after we do the simulation, we can do the testing in the laboratory HB as to see the result is tally or not with the simulation that has been done in the software of console, for example.
Okay, as for the result, this model is designed to analyze a single insulator cap and pin before it is joined to a string insulator. Figure on the left side shows the potential of a distribution contour across a single insulator. The contour red color shows that distribution contour across the insulator has the largest potential in the area closest to the pin. As figure on the left side shows the equipotential lines of electric field distribution are shortened in the region closest to the steel pin. Okay, next. This two figure shows the strength dependent on the creepage clearance, which is the left side is potential and the right side is the electric field. The maximum voltage for electric potential is 134,712 volt. Okay, next is the figure of layer contamination that has been applied with specific relative permittivity and electric conductivity. As mentioned before from my friends, the layer of contamination is water. Okay, next, this is the figure of performance with and without contamination. This is the performance of electric potential. As you can see here, the graph is decreased like stairs. And this one is the strength of electric field. Based on the figure before, this is the maximum and minimum electric potential and electric field. It is observed that the voltage in contaminate is slightly lower than clean insulator, so there are tiny difference between maximum and minimum.
Okay, lastly, the conclusion from the FEA simulation. In overall, the glass insulator design meets a few of the criteria for a good insulator, and the console multiphysics was used to verify the insulation's performance in terms of its electrical potential and also the electrical field between the contaminated and also the non-contaminated insulators. The high voltage testing is essential for ensuring that the equipment is in a good working order before being put into a service. When conducting a high voltage testing, all precautions must be taken to ensure its safety. Okay, next, this is the code of conduct for the testing of glass insulator by using the HVDC dry and wet test. The DC voltage supply may come from a two-stage Horton Cockcroft generator that has a rated voltage output of 500 kV with 7.5 mA. Its ripple factor was lower than 3% and the voltage drop is lower than 10% at its maximum load current. The breakdown voltage is measured with a resistive potential divider. The voltage is supplied to the insulator and it is raised until the flashover occurs. The flashover voltage is then recorded and the test is repeated for 5 times. This is done to both dry and wet tests. For the wet test, the insulator is sprayed throughout the test with artificial rain that comes from the nozzle. This is the precipitation condition for the standard procedure. The rate of rainfall for both the vertical and the horizontal component. This is the resistivity of the water, the angle of rainfall, and also the temperature. Before starting, all equipment must be tested to ensure the capability of the overvoltage to withstand during the operation. To avoid any heating problems that will lead to the fire hazard, the setup was also grounded properly so that the personal hazard will not exist, as it is necessary to ground the high voltage circuit before working on the test subject. The safe grounding of instrumentations should take precedence over proper signal grounding unless the other special precautions have been taken as consideration to ensure the safety. The safety equipment such as the insulated boot and gloves to minimize the hazard of being electric shocked. The use of a face shield also needs to be taken into consideration in case a breaking glass insulator can occur during the testing. Lastly, the clearance of the conductor to other external structure also must be 1.5 times to the length of the insulator dry arcing distance.
For the conclusion of HV testing, in conclusion, the high voltage testing of the insulator was conducted in both conditions. First is wet and second is dry condition in the high voltage laboratory. As for the wet condition, it needs rinse as the sample. Meanwhile, it uses a nozzle in the lab to spray the water to the insulator. In the dry condition, we does not have the sample to do the testing. Lastly, all the testing guidelines will be to ensure safety and minimize hazards during the testing in the lab. I think that's all. Thank you for watching.